Okay, let's start off today talking about something that's been in the news a lot lately. It's a pretty interesting thought here. Traveling to the moon. So, with all this talk of traveling to the moon, can anyone tell me how long it would take to travel there? Give you a couple minutes to think. If you want to answer by car, if you want to answer by plane, by jet, by spaceship. Okay, so got a couple people typing in some answers here. Um, all right. Well, lots of good thoughts there, but here's the answer. The best way I think to think about it is if you were going to travel there by car. So if you were going to hop in the car and go to the moon, it would be about 3,400 hours, and it would take you 141 days if you were driving at 70 miles an hour. Wow, that's that'd be a long ride. I wouldn't even want to think about it. So Uh, what does that tell us? Well, that tells us that even though sometimes we look at the moon in the night sky and it looks like it's kind of close, it's really, really, really far out there. And then when we start thinking about the sun, we want to think about today in today's lesson, how far away is the sun? So we want to look at the comparison between the Earth, Moon, Sun, how far apart they are, and how big they are in comparison to each other. So that's what we're looking at today. So the first activity I want you to do is I want you to um, I want you to tell me how do they compare. So in this picture, I have the Earth, Sun, Moon. I made them all look the same. Well, that's not true in real life, not even close. But there's the pictures of them. So what I'd like for you to do is somewhere on a piece of scratch paper, or if you want to pull it up on your computer, I want you to sketch it out and kind of give me an idea of what you think would be the relationship in size and distance. So what's closer to each other, and then put something in there about size, about how big you think like the Earth is compared to the Moon, and then compared to the Sun. Okay. So everybody's got their ideas down there, doing a little brainstorming. So while we're talking here with what you put down, which is the biggest? Is it the Moon, the Sun, the Earth, or are they all the same? So go ahead and use your polling tool here. Give me your idea, A, B, C, or D. I think I already told you that they're not all the same, so you better not answer D. So let's see, A, B, or C. All right, so who guessed the sun? Let's see. Oh, about 80% of you said the sun is the biggest. Okay, that's pretty good. And the Earth, we have about, oh, okay, the other 20%. Nobody said the moon. That's pretty good. So most people think that the sun is the largest, and a couple people think the Earth is. Why do we think that? Why do 80% of you think that the sun is the largest of the three in that system? Anybody want to give me a thought? Okay, you can go ahead and tell me. Okay, so you think that you're saying that it's really far away and it still looks pretty big. Okay. And then I heard someone else say that it's because it's got to be the biggest. It's the center of the solar system and everything is revolving around it. That's a pretty good answer too. So, all right. So the correct answer is the sun. So 80% of you were correct. So let's look at how big the sun is here. I typed this out a little bit here, and I got some pictures to try to put this in perspective. It would take 110 Earths side by side to go from one side of the sun to the other. So here's the sun, here's the Earth, and this picture here is actually going to show you a little bit of math. It's showing us 11 Earths to go across Jupiter, but then it's showing 10 Jupiters going across the sun, so we'd have to do 11 times 10, and that would be your 110 Earths. I think we were using this comparison here because you wouldn't even hardly be able to see them if you put 110 little Earths side by side. So that tells us that the sun is massive. And then what comes next in size? Well, that would be the Earth. And then we see here that it would take about 4 moons side by side to cross the diameter of Earth. So when we're looking at size, we're going to say the sun is by far the biggest, then the Earth, and then the moon. Uh, So I'm not quite sure. I've tried this before. It's really hard to show that on a piece of paper because how can you show that on a piece of paper where a sun is 110 times the diameter of the Earth? Well, you'd have to draw the sun as a size relationship really big, and then the Earth would be small, and then the moon would be like a speck with your pencil. So really hard to draw these three as a size comparison. That's why we're looking at it today. It's just hard for us to wrap our minds around this. So now that we know that, here's the next question. If the sun is that much larger than the moon, then why do they look similar when we see them in our sky? And I want you to type your answer in the chat box so we can all put our heads together on this. And I got a bonus question here. If someone can tell me what this is a picture of here in the background. Anybody want to tell me that real quick? Think about it while you're typing your answer in the chat box. What we're trying to say is, what we're trying to look at is if the sun is that much bigger than the moon, obviously, if it's massive compared to the moon. So why are they able? Okay, someone said, there's the bonus question. Good job. Someone said that this right here is showing us a solar eclipse. So what we're seeing here is we're seeing the sun and we're seeing the moon pass between the sun and Earth, and the moon appears to be exactly the same size as the sun. So that's why this is so tricky for us to understand, because here on Earth, when we look at the moon and the sun at just the right time, they look exactly the same size, but we know that's not true. So why um, why do they look the same? Okay, let's see the answers. Good. Someone typed the sun is so much farther away than the moon, so therefore it would have to be much bigger to appear to be the same size. So it has to do with distance. That would be the answer to this. Has to do with distance away from Earth. Okay, so let's put a statement in our notes to get all these thoughts together. You guys have some stuff sketched on your paper there. I'm sure not every, but I'm sure that some people had some stuff written down that was not even close to correct, but that's how learning happens. So let's try to get this all down on a piece of paper and get our thoughts together. So how could we draw this? Well, here's what I would do. I would draw something in my notes that appears something like this. Here's Earth, here's Moon. Earth is way to the right, Moon's next to it, and here's the sun over here. Is this picture right here even close to being correct? Not really, because the sun would have to be even bigger than that, because remember, it takes 110 of these Earths side by side. So when you're drawing this in your notebook to make sense of that, you want to make sure that you draw the sun really big and you draw the Earth and the moon over here way far away from the sun, and then you can make some notes so that you can remember that the moon, there was be 4 moons across the Earth, and then over here you might want to make some notes that it would take 110 Earths to cross the sun. But this picture here is something that just always has blown my mind ever since I was in college and I was learning this stuff. And I think about that picture of the solar eclipse. That the reason that the Earth, or the reason that the sun and the moon appear to be exactly the same size when we're standing in our backyard during a solar eclipse is because the distance from Earth to the sun is 400 times greater than it is than the width of the okay, let me get this straight again. The distance from Earth to sun is 400 times greater than the distance from Earth to the moon. Okay, but the width of the sun is 400 times greater than the moon. So when we have the distance is 400 times greater and the size is 400 times greater, they actually line up perfectly in our sky. So what would happen? Can someone tell me what would happen if, let's just say, the moon were just a little bit farther away from Earth? Would we ever have an eclipse? Yeah, we would. Or would we? Good question. Someone says yes. Would we be able to have an eclipse if the moon were just a little bit farther away than it actually is? No, we wouldn't, because the moon would appear what? Smaller. The sun would appear the same size. So when we look at that eclipse that we saw back here, the moon would actually be just a little bit too small to cover up the sun. So we would never see that. So it just so happens that the moon is the perfect distance from Earth to cover up the sun because 400 is the magic number. All right, so hopefully in that little lesson there, you have a better idea about the Earth, sun, and moon. Okay, so that was my short little 10-minute lesson there, trying to, teach the idea of the Earth, Sun, and Moon as a system and size and distance relationships. It's obviously a pretty big topic to cover, but I wanted to give you an idea there of how I would approach that. I, Going back to the beginning there, I tried to activate the prior knowledge with traveling to the moon because most students have probably seen something online or somewhere they've seen something about moon, us traveling to the moon with kind of the race of privatizing that and all that. So I just don't think that they really have any idea how far or how long it would take. So that kind of gets them thinking about, okay, well, if we leave Earth, the moon during a full moon, you look up there, it doesn't look like it's that far away, and then you start thinking about that distance, and then we jump onto the sun, and that's just an extreme distance. So trying to make sense of that. Anytime you talk about huge numbers and distances with anybody, it becomes very difficult, but especially with middle school students, that becomes really difficult to try to make sense of those big numbers. So if I just threw numbers out there of how many miles it was, I don't think it would really. I just don't think it would have any effectiveness. They could write it down, but I don't think it would really mean anything. So tried to activate the prior knowledge of how far they thought the moon was, and then I really like to have them draw that picture to start with, just to make a sketch and see what they think about the size and distance relationship of the three, because nobody's going to get that right on the first try, and the idea is just to try to see how they would compare the three, and and then as we moved on through the lesson there, I used some polling tools to kind of see what people thought and kind of know what I was working with as far as their prior knowledge. And as we moved farther into the lesson, I got to the point where I said that I wanted them to, be able to take some notes on that. And what I would have done at that point, I put it, let's go back here. Oh, my computer's stuck there. But it was the part where I said, okay, let's take some notes on this. What I would have done there is I would have put up a clean screen and showed them exactly what to write down so that they would have a perfect copy of what I wanted them to put in their notes. And I also like the idea. I've used this in the past, and I'm not sure with online learning. I would be the first to admit I'm not sure how to do this with online learning. I'd have to, talk to my colleagues on this as far as how note taking goes. If kids still use a regular old notebook or if we're taking notes, on the computer. But I always like to have that picture that they originally drew, and then what I call a line of learning. Draw a line below that and draw the actual picture of what it's supposed to be, because when you go back and look at that, days down the road, uh, it's pretty neat to see. Okay, here's what I used to think, and here's the right thing, and now I've learned something. So I always like to call that the line of learning. What's above the line is what you thought, and what's below the line is what's actually correct. So I use that technique quite a bit, and for kids that have kids that have trouble with the reading comprehension, I try to use as many pictures as possible, and I tried not to get into too much math calculation here. I kind of did the calculating for the students. I think sometimes you can get too much math involved in the science, and then you end up not teaching the science because students are struggling with the math. So I don't want to put too much of an emphasis on that. However, maybe in an upper level class, that would be a great chance to kind of do a little cross curricular activity there to have those kids do the math with the science, if you had a class that was capable of that and it wouldn't hold them back. So that's my thought on this little lesson right here, to get them to be thinking about the Earth, Sun, and Moon as a system, and try to overcome their previous ideas of how these things exist. Thank you.